There is a trick that costs less than $1. A piece of felt, a tablespoon of baking soda, a thin coat of petroleum jelly. And when you apply it to your car battery terminals, something happens that battery manufacturers and car dealerships have spent decades hoping you would never discover. The corrosion that slowly strangles your battery stops forming. The connection resistance that has been stealing starting power from you every cold morning drops to zero. The battery that was showing 300 cold cranking amps when it should be showing 500 gets its power back. And the replacement your dealer was about to sell you for $170 stays on the shelf. $1, 15 minutes, 3 additional years of battery life, minimum. Battery terminal corrosion is the single most common and most overlooked cause of premature automotive battery failure. Not cell degradation, not deep cycling, not manufacturing defect. Acid vapor corrosion at the terminal posts. The white, blue, or greenish powder you see building up around your battery terminals is not cosmetic. It is not a sign that your battery is old. It is an active chemical attack on the electrical connection between your battery and your vehicle, and it has been happening since the first lead-acid battery was installed in the first automobile in 1910. Then someone in a corporate boardroom did the math. The automotive battery replacement market in the United States generates over $12 billion annually. The average battery costs between $100 and $200 at retail. The average vehicle goes through 3 to 5 batteries in its lifetime. A $1 treatment that doubles battery terminal life and extends battery service life by 2 to 3 years is not a maintenance product. It is a revenue subtraction event. And what subtracts revenue from a $12 billion market does not get promoted at the dealership service counter. Welcome to Forbidden Fix. If these stories matter to you, hit subscribe and the bell. This is where we dig up what industries spent decades trying to erase. To understand why this $1 treatment extends battery life and restores starting power, you need to understand what lead-acid battery terminal corrosion actually is, why it forms, and what it does to your electrical system. Your car battery contains sulfuric acid electrolyte at roughly 37% concentration. This acid is necessary for the electrochemical reactions that store and release electrical energy. But sulfuric acid produces vapor even at room temperature. Hydrogen gas is also produced during normal charging and discharging. Both gases escape through the battery vents and accumulate around the battery terminals and cable connections. When sulfuric acid vapor contacts the lead alloy terminal posts, it reacts to form lead sulfate, which appears as white crystalline deposits. When hydrogen gas and sulfuric acid vapor interact with copper in the cable connectors, they produce copper sulfate, which appears as the distinctive blue-green powder. When these deposits form on the terminal posts and cable clamps, they create an insulating layer between the metal surfaces that should be in direct electrical contact. The consequences are not subtle. A connection resistance of just a few milliamps at the terminal can cause a voltage drop significant enough to reduce starter motor torque by 15 to 20%. That is the difference between an engine that cranks and fires on the first attempt, and an engine that clicks weakly and fails to start on cold mornings. The battery's actual electrochemical capacity may be perfectly adequate, but the resistance at the terminal prevents that capacity from reaching the starter. The battery tests as failing when tested through corroded connections, because the tester measures the voltage delivered through the connection, not the voltage stored in the cells. Dealers replace batteries that have adequate remaining capacity because the corrosion makes them test poorly. You pay $170 for a new battery that performs identically to the old one until its terminals corrode in the same way. Baking soda is sodium bicarbonate. Its relevance here is fundamental acid-based chemistry. Sulfuric acid has a pH of approximately 0. Sodium bicarbonate has a pH of around 8, 3. When you apply a baking soda and water solution to corroded battery terminals, the alkaline bicarbonate reacts immediately with the acidic sulfate deposits. The reaction produces carbon dioxide gas, which you see as vigorous fizzing, water, and sodium sulfate, which rinses away harmlessly. The acid deposits are neutralized. The terminal surfaces are returned to bare metal. The connection resistance drops to near zero. The battery's full capacity is available to the starter again. This is high school chemistry applied to automotive maintenance. And it works exactly as predicted every time. Petroleum jelly, or Vaseline, serves the second function. And once the terminals are clean, petroleum jelly applied to the post surface and the interior of the cable clamp creates a barrier impermeable to acid vapor. The jelly is not conductive. It does not improve the electrical connection. But it does prevent acid vapor from accessing the bare metal surface. New corrosion cannot form under the petroleum jelly seal. The terminal remains clean indefinitely. Most mechanics and battery manufacturers recommend replacing the petroleum jelly barrier at each oil change interval approximately every 5,000 miles, which takes 30 seconds and costs nothing. The felt terminal washers sold at auto parts stores add a third layer of protection. They are pre-saturated or hand-saturated with baking soda solution and placed between the battery post and the cable clamp. As acid vapor rises from the battery vents, it passes through the alkaline felt washer, which neutralizes it before it can reach the metal contact surfaces. The felt acts as a continuous acid vapor trap. This is not a new invention. Felt terminal washers have been sold at auto parts counters since the 1960s. They cost approximately $1 for a pair. They prevent the formation of the corrosion that is currently costing $12 billion annually in premature battery replacements. Before I go further, this video covers the terminal protection method. Inside the Forbidden Fix vault, I've compiled complete battery maintenance guides covering cell conditioning, load testing procedures, desulfation techniques, deep discharge recovery, and the exact maintenance schedule that fleet vehicle operators use to extract 5 to 7 years from batteries that typically last 3. The link is in the description. But stay right here, because the economics of battery replacement are the most straightforward example of preventable consumer spending in the entire automotive industry. The United States military has maintained battery terminal cleaning and protection as a mandatory maintenance step in vehicle maintenance schedules for every wheeled and tracked vehicle since World War II. Army TM 9228910 and related technical manuals specify battery terminal cleaning with baking soda solution and protective compound application as scheduled maintenance items, not as a suggestion, as a requirement. Commercial fleet operators, school bus companies, municipal vehicle fleets, and rental car companies all clean and protect battery terminals on schedule because a battery failure in a commercial vehicle is a cost event that exceeds the cost of 30 seconds of maintenance by a factor of 100. The practice is universal in fleet management. It is only absent from the consumer maintenance relationship, where the battery failure is not a cost center. It is a retail opportunity. The automotive battery replacement market is structured around a predictable failure timeline. A standard lead acid battery under normal use and no terminal maintenance will develop significant corrosion within 18 to 36 months. That corrosion progressively degrades starting performance. By 3 to 4 years, the corrosion-induced voltage drop causes the battery to test as failing. The owner purchases a replacement. The cycle restarts. With proper terminal maintenance starting from installation, the same battery will often deliver 5 to 7 years of reliable service, 2 to 3 times the unprotected lifespan. The terminal maintenance supplies cost less than $5 for the life of the battery. The battery costs $100 to $200. The math requires no explanation. If you have made it this far, you now understand more about electrochemical corrosion and battery terminal physics than 99% of car owners being sold a replacement battery for a vehicle whose existing battery was electrically adequate. Subscribe and share. One share might save someone from buying a battery they did not need. Here's exactly how to do it. Step 1. Gather your materials: baking soda, water, a stiff bristle brush or old toothbrush, petroleum jelly, and felt terminal washers if available. Cost under $1. Step 2. Disconnect the negative terminal first, always, then the positive. This order prevents accidental short circuits. Step 3. Mix 1 tablespoon of baking soda in 1 cup of warm water. Pour this solution directly over the corroded terminals. You will see immediate vigorous fizzing as the bicarbonate reacts with the acid deposits. This is the neutralization reaction in progress. Step 4. Scrub the terminal posts and the inside of the cable clamps with the brush. Remove all white, blue, and green deposits. Rinse with clean water, dry completely with a cloth. Step 5. If using felt washers, place them over the clean terminal posts before reconnecting the cables. Saturate them with the remaining baking soda solution. Step 6. Apply a generous coat of petroleum jelly to each terminal post and to the interior contact surface of each cable clamp. Step 7. Reconnect the positive terminal first, then the negative. Tighten securely. Apply a final coat of petroleum jelly over the entire connection. Step 8. Test starting performance. Most owners report an immediate and noticeable improvement in cold start cranking speed. Total cost, under $1. Compare that to the $170 replacement battery sitting on the parts counter. I need to be honest with you. This method maintains and restores terminal connections. It does not recover a battery whose internal cells have genuinely degraded beyond their service life. If your battery is over 6 years old and tests below 12.4 volts when fully charged and rested, the cells may have reached end of life regardless of terminal condition. If the battery plates have sulfated due to repeated deep discharge, terminal cleaning alone will not restore capacity. And if your vehicle has a charging system problem, either an underperforming alternator or a parasitic drain, no amount of terminal maintenance will compensate for a battery that is chronically undercharged. Have the charging system tested at any auto parts store for free before spending money on a battery. Always disconnect the negative terminal first and reconnect it last. Reversing this order risks sparking near the battery, which can ignite hydrogen gas accumulations around the vents. For 100 years, battery terminal maintenance was standard practice. Your grandfather cleaned his battery terminals every spring with baking soda before the car went back on the road after winter storage. He brushed off the corrosion, greased the terminals, and the car started every time. Then the automotive industry commoditized battery replacement. They made it fast, easy, and convenient. 3-year battery warranties calibrated precisely to the average corrosion timeline, roadside assistance programs that replace batteries on the spot, quick lube chains with battery testers that measure voltage through corroded connections and recommend replacement. The replacement was never necessary. The maintenance was. There was not a better battery. There was just a better maintained one. Subscribe and share. Every share preserves what they tried to erase. The next vault opens soon. And what is inside might explain how a $2